Hello AP Calculus students. Here is an integration technique called long division. So if you are trying to figure out how to do an antiderivative and by memory is not helping, or u substitution is not helping, or other techniques, long division might be the one that can be utilized. So this goes back to long division that you would have learned in algebra. And in this case, we're dividing x plus 1 into 6x squared minus 7x plus 2. So this is our traditional way of setting this up. You can also use synthetic division, I suppose, but I'll just use this method for right now. The first question you ask yourself is, what do you multiply x by in order to get 6x squared? And the answer is 6x. And then you multiply that 6x, or distribute that through the x and the plus 1. So you end up getting 6x squared plus 6x. And then you subtract these two terms from the two terms in the original equation there. So the 6x squared minus the 6x squared is going to be 0. That's kind of the purpose of getting rid of that. And then you have negative 7x minus 6x to get negative 13x. And then you bring down your next term, which in this case is plus 2. And then you go through the process again. So you're going to ask yourself the question of, what do you multiply x by to get negative 13x? And the answer is negative 13 or minus 13, and then you distribute that over. And so then you get negative 13x minus 13. And again, you subtract these terms. So the negative 13x cancels, which is the goal, and then you have 2 minus a negative 13, and so your remainder down here is going to be positive 15. All right, so what this means then is that we can rewrite this fraction inside this integrand. We can rewrite this as 6x minus 13, which is what we get from our work here, okay? And then you have a remainder of 15, so plus 15, and that's divided by our x plus 1. And now what we can do is just take our antiderivative really easily using our old techniques. So we have our power rules, 3x squared minus 13x, and then this is going to be 15 multiplied by the natural log of the absolute value of x plus 1, and then this is a general antiderivative, so then we have plus c, and that's your answer.